Good morning, friends. Yesterday, we had a discussion regarding the properties of triangle, in which I had explained to you one of the tools or the formula to calculate the relationship or establish the relationship between the sides and the angles of a triangle. Yesterday, one of the formulas known as sine formulas was discussed with you. Today I will be discussing one more formula, which is known as cosine formula for a given triangle. That is, this is the another tool to establish the relationship between the sides and angles of a triangle. So let us see the other formula or the other tool establishing the relationship. The name of the formula is cosine formula. This particular formula can also be applied in an acute angle triangle as well as an obtuse angle triangle. As it was the sine formula which was establishing the relationship between the three sides and the three angles of the triangle, the cosine formula establishes the relationship between the three sides and one angle of the given triangle. Means, if you want to establish a relationship between the three sides and one angle of the given triangle, be it an acute angle triangle or an obtuse angle triangle, the relationship can be drawn from the cosine formula. I deduce or derive the formula in front of you. First of all, we will be seeing the cosine formula for an acute angle triangle, and then we will be seeing the cosine formula for an obtuse angle triangle. First of all, I would like to write the formula which is applicable out here. The formula goes like this: a square is equals to b square plus c square minus 2bc cos a. A square is equals to b square plus c square minus 2bc cos a. B square is equals to a square plus c square minus 2ac cos b. C square is equals to a square plus b square minus 2ab cos c. These are the three formulas which are known as cosine formulas. As you can see, the small a, small b, small c represents the three sides of the triangle, while the cos of angle A, cos of angle B, cos of angle C represents one of the angles of the triangle. That is why I told you that this particular formula or tool is used when three sides of the triangle and one of the angle, we need to establish a relationship between the three sides of the angle of the triangle and one angle of the triangle. So let us see, we derive these formulas for an acute angle triangle and for an obtuse angle triangle. Please see to it how we derive it. A, B, C. This is an acute angle triangle, and for naming the sides, I told you yesterday that if you have this vertex as A, the side opposite to this vertex will be named as small a. The side opposite to vertex B will be named as small b, and the side opposite to vertex C will be named as small c. I have three sides which has been named as A, B and C, while the triangle has the three angles, angle A, angle B and angle C. All of the 6 parameters are forming a triangle. Now I will be deriving these formulas for this particular triangle, that is the acute angle triangle, for the syllabus cosine formula. Please see to it. It goes like this. for the derivation part. I will be doing a construction within it. I will be drawing a perpendicular from vertex B onto side AC. This is a construction which I have carried out. After doing the construction, I can clearly see there are two triangles being formed here. One is triangle ABD, that is the right angle triangle, and the other is triangle BCD, that is the other right angle triangle. Both these triangles which have been formed here are right angle triangles. Applying Pythagoras theorem on triangle BCD. Applying Pythagoras theorem on triangle BCD, which says that BC square is equals to BD square plus DC square. BC square is equals to BD square plus DC square. Now substituting the values, I get it as BC square A square is equals to BD square plus AC minus AD whole square. Please see to it. What I have done is I have resubstituted the DC part as AC minus AD the whole square. Now opening it, I get it as A square is equals to BD square plus AC square plus AD square minus 2AC into AD. This is the A minus B whole square formula which I have applied out here. As we can see that AB square and AD square are forming a right angle triangle out here also. So out here we have the formula BD square plus AD square, BD square plus AD square, BD square plus AD square will be equal to AB square. So again substituting that value, I get it as AB square plus AC square minus 2AC into AD. Substituting that value, I get it as the name of the side AB is C. I get it as C square plus B square minus 2B and AD can be written as C cos A. You see it, cos A in triangle ABD is AD upon AB. Therefore, AD can be written as AB cos A. AD can be written as AB cos A. So out here the AD side is written as AB cos A. The AD side is written as AB cos A, giving the derivation as A square is equals to C square plus B square minus 2B. AB cos A, AD is equals to AB cos A, and the value of AB is C. So it becomes A square is equals to C square plus B square minus 2BC cos A. So this is the formula derivation for the cosine formula of solution of triangle. This is the another tool to establish relationship between the sides of the triangle and angles of the triangle. This is the first part which we have derived. The other two parts can be derived in the similar way by just changing the name of the triangle. Okay, or you can start with this part. You can take this triangle and apply the Pythagoras theorem. For proving the first part, I have taken this triangle. You can apply the second triangle and apply and get the other results out of it. Okay, thank you.